Hi, I'm Sam Guraya, the project manager of the Mega Blow and Mega Mow project. Ultimately, this project is trying to build a self-automated vehicle robot that is a two-in-one snowblower and lawnmower. The purpose of this project is to first make arduous tasks easier to complete, allows users to use their time more efficiently, and three, prevents injuries for the users from performing the task themselves. Some of the success indicators of this project include is that it meets the project objectives, such as it's able to successfully pick up cut grass and eject snow. It should also be able to survive a variety of weather conditions, such as rain, snow, and it should be able to successfully interpret its surroundings.
The robot should be able to automatically mow a lawn or clear a driveway of snow. The user should be able to program what time at which they want the robot to do this, the same way you program your phone to wake you up every morning. The robot should also be easily configured by the user, as in it should be easy for them to set it up for their lawn or their driveway. The robot should also work with a positioning system that depends on two separate entities: the servo motor rotation to track linear motion and an accelerometer to track rotational motion. The robot also has a set of checkpoints that it should reach, which are in the form of RFIDs that are preset by the user. As in, the user should take these RFID checkpoints and place them strategically around their lawn, at specific checkpoints around the lawn.
So if this is not done easily by the user, then the project was not successful.
So any project has a lot of constraints, so we limited ours to 5 particular constraints. It has to be done in 2 months. It will weigh 45 kilograms. At most, it will charge to 100% in 5 hours. The height of the project itself will be 2 feet tall in order to blow the snow, and it requires a budget of $1,500 at most.
Using the work breakdown structure, we have made a master budget. The cost of each deliverable was determined by how much money was being used to either build or acquire parts to complete that deliverable. Using the bottom-up method, you can see that most of our money is being used in the construction of the servo. In addition, you can see the project will cost around $1,060, which is within our budget.
The Mega Blow Mega Mow is going to consist of a positioning system, mechanical parts such as this lawnmower and snowblower, and the wheels, the control system to control those parts and to control the positioning system, and finally, it's going to consist of a power system which has a charging side and then a power delivery side with a power regulator and batteries to supply power, and then inductors to charge the robot itself. We're going to have to create a battery array, a power regulator that can supply power to the microcontroller and to the motors in order to operate the machine. We will have to program a drive turn module in order to power the servo wheels, and it should also, in order to turn, it's also going to have to control the positioning system, which tells the microcontroller what the orientation of the robot is. We're also going to have to program fault detection in order to, for safety purposes. We'll have to program a way for the user to create their own paths for the robot to follow.
So these are the risk events that are likely to occur in our first stage of prototyping and testing. The risks have a certain likelihood, impact, and the detection difficulty, and the most the criteria when they're most likely to occur. We have designed a certain scale for every certain aspect for the risk, from 1 to 5, where 1 is the least and 5 is the most. And this chart is self-explanatory.
For the risk assessment matrix illustrated before, we have now come up with a risk response matrix for each of the risk events. So if the risk events take place, first of all, we have an immediate response in action. And then after the immediate response to each risk event, we have a contingency plan in place for all the risk events particularly. And then if the contingency plan fails for the particular risk event, then there's a trigger where you have to do after the contingency plan fails for each particular event. And then then we seek out the person who is responsible to fix the problem, or who's gonna find out what the initial problem was and why the event took place.
From the work breakdown structure, we have completed a critical path analysis. Using the legend and the days required to complete the deliverables, floats were calculated. Marked in red, 2 critical paths can be seen. They go from ordering parts, making the chassis, attaching the snowblower and lawnmower parts, connecting the sensors, testing hardware, and integrating and testing the server itself. Scope throughout a project could potentially change. Here are some reasons why SR can change and how we integrate it into our project. For example, housing designers are finding it difficult to prevent their server hardware from getting damaged from rainy conditions. Our issue would be that the server will be unable to survive wet weather conditions. Our solution would be to have coders design a program that allows the robot to know what region it is in to see if rain will occur to ultimately warn the user. In addition, we will warn the user of this in manuals. Our person in charge would be Abdul Haseeb, and the person in charge of coding would be Sam. The communications and reporting plan discusses how communication of the project status with sponsors will occur. It covers the form of communication with sponsor, the frequency, originator, distribution flow, and any comments. For example, communication within the project team will be meetings that will be held weekly, originator being the project manager, and the distribution flow being whether the project team is on track of the critical path.
We would like to thank Dr. Lee for sponsoring this project. We would also like to thank our functional manager, Siddharth Date, for helping us and guiding us through this project. Thank you so much.